So who here, like maybe you want to put up your hands or like shout out, like would anyone call themselves a functional programmer or know anything about functional programming? I don't know. I did university like 400 years ago. And I think we did a little bit of functional programming at university, but it wasn't a big deal back then. Someone's hands up. That's good. Muhia. Is it Muhia? Muhia.
Yes, it's Muhia. Yeah.
Yashin. Yeah, tell me. What do you know about functional programming?
Functional programming for me, I think it's a programming methodology where you focus on what to do rather than how you do it. So
yes,
yeah, that's what I know.
That's a flipping great answer, by the way. Yeah, absolutely. Yeah. So it's a very difficult term to define because so functional programming, actually the word functional is a terrible word because like what it talks about is it's a language that uses functions. And it's like, well, like I don't know many languages that don't use functions, right? Like C# has got functions and Java's got functions and Python's got functions, right? So functional programming, the word is a bad one, but when you contrast it to another language like an imperative language, so you get imperative languages, which are like, it's all about the imperative. And so when I think about the word imperative, it means like steps. It's very much like step driven. It's like do this, then do that, right? Whereas functional programming often is more about like, it's more about the what am I trying to do rather than how am I trying to do it. And then just kind of using it's called like reduction to solve the problem. And it's very much the same as what you would do in maths. So you'd create functions in maths and then you just reduce them to their solution. Do you know what I mean? It's not like like in maths, there's no for loop. There's no like real, like repeat while or do this while, like do these steps in order. Maths is like, no, I write out the entire equation and I can reduce it to its answer. It's not like there's steps that need to occur while this thing happens. Do you know what I mean? And so I think when it's contrasted against imperative programming, that's kind of like what functional means. It's really, and I think your answer of saying it's more about the what. So describing the problem rather than describing the solution to the problem, if that makes sense. So I've got a couple of. Does anyone else want to say anything? By the way, there was another hand up and then it dropped down. Was it Yashin?
No,
go.
Tom, like we never learned about it in university, but I remember reading about it on FreeCodeCamp, and and like you said, it uses functions, but it's further broken down into two functions, whether the function is a pure function or an impure function.
Yes.
And coming back to the mathematical concept that you mentioned, like you said, in C# or in Java, we can use all these loops, but this thing is not focused on the loops. So it comes from the mathematical construct that you spoke about.
Yeah. So you've hit another perfect point, which is purity in languages, I suppose, and mostly it is around functional languages that have got this thing around purity. So it's how pure a function is. So you get pure functions and you get impure functions, and we'll talk a little bit about purity later. But like as a summary, a pure function is one where it is the mathematical definition. So given these inputs, I will always receive these outputs, if that makes sense. So if I give this function a 3, it's going to give me back a 4. Like if it's a +1 type function, right? It adds 1 to its input. That's a pure function because it's dependent on no other state around it. It's absolutely pure. So it doesn't matter what I give it as long as it's an integer, for example, as long as, like, of course you can constrain your inputs, but given a 3, it will always return me a 4. It doesn't matter whether the database is down or the file system is dead or the network is disconnected. If you give this function +1 a 3, it will give you a 4. You know what I mean? It's absolutely, it has no dependencies other than its inputs, if that makes sense. And so that's what what purity is all about. So a pure function is one where, and there's interesting properties. So you might say, well, that's like, who cares whether it's pure or not? But if you know that a function is pure, you can do certain things with that function in order to optimize it. So if you always know that a 3 calling this function gives you a 4, and someone else later calls 3 with this function, it's like, I could have remembered that the answer was 4. And like, you don't even need to invoke the function, right? So you can start to do some interesting optimizations around pure functions. Sometimes you also don't even need to call them. Whereas something that's impure, it has a dependency. So if I call the function with a 3 and it looks up how much it needs to add to it from a database, and it then figures out that it's a 1, it means that next time I call this function that, you know, it could return a different value. So that's no longer a pure function, if that makes sense. And yes, you can totally separate the world into pure functions and impure functions. And good functional language, or I shouldn't say good, but I should say like very strictly functional languages separate that very, very well, separate the pure from the impure very well. Whereas more looser functional languages, or even looser imperative languages, kind of just muddle those things together. And they just say it doesn't matter whether your function is pure or impure. It's just in the way you write it, but nobody cares whether it's pure or impure, if that makes sense. So I think we'll talk about purity a little bit later. I think I've got some stuff to like illustrate it maybe. So these were my reasons for like why FP. So why would I want to like research or study functional programming or use functional programming? And these are some of like the like popular opinions as to why. So for sure, less bugs, absolutely. I believe so. So I think writing code in a functional way does tend to have less bugs, because and we'll get into like, I think this is an interesting space, and this is really like beginner level stuff. So this is where we'll focus. So things like null, the concept of what is null, mutation and side effects, which is that purity impurity thing, like do not exist inside pure functional languages, and those things are very often a huge source of bugs. So null, mutating stuff, and side effects are a big source of bugs. So a very strict functional language may remove those things entirely, or they'll put them into a clever little box to help you manage them, manage those side effects. And so like less bugs means less testing, that kind of stuff. It doesn't necessarily mean that the code is written faster though. Like don't connect less bugs with like more code. I'm not sure. We can talk about that. But another good reason might be better performance. So potentially better performance. So I talked about this a little bit earlier, but like having a good language which has a stronger type system allows a compiler to potentially optimize code better, if that makes sense. And even do stuff like, hey, this guy never calls this function or never calls it with these kinds of inputs. So in fact, like let's never invoke that thing, right? So and that's called being lazy potentially. So if your compiler is a reduction one, so it reduces to the answer, things that are not part of that reduction tree like never get executed. Whereas in a imperative language where you say do this, then do that, then do that, guess what? You've done all three of those before you get to the answer. If the answer at the end never needed you to do the second step, like in your imperative world, you still did it. Like that's wasteful, right? Whereas a functional language it jumps right to the solution and it says, okay, I'm going to do this, and in order to do this, I need to do step 1 and step 3, and then resolve to the answer. Guess what? It just skipped step number 2. And so the idea of that is like is this idea of this concept of laziness. So if you write a program that does a whole bunch of stuff and you never print the output, your program may never need to get that, never need to like run that calculation because you never used it. So like, why would it even go and fetch it, right? Or calculate it? So functional languages or good, strong type systems can sometimes be interesting because compilers can leverage them to find areas of optimization, which I think is pretty cool. Whereas in imperative language, it can't. Like the compiler just goes, cool, I'll do that, then do this. It doesn't really know that the output of this one may not be used in the final result because of the purity concept. Actually, it doesn't know that calling this function doesn't make some external change somewhere, so it can't skip it because it just doesn't know that this is a pure function. Whereas a pure function, you can skip it if you never need to use it, never need to use the result of it. But like, it's getting a little bit hand wavy, but it's interesting. Easier to scale potentially, yes. This I have like real experience with. So as like system architecture is becoming more and more distributed, and this is a big topic, guys. Like this is something I'm very like passionate about, is distributed computing. But like the more code that is now being run across many machines at the same time to achieve like a single task, the more you want more of a functional type of approach. I can dive into the detail of why that is, but it really comes down to like state and mutation. Where does state live, etc. And functional styles are often a nicer style that allows the distributing of computation to more than one node. And so certainly at Synthesis, I mean, you guys know that we do a lot of AWS cloud, and we build microservices, and we use Kubernetes, and we like that kind of stuff. So like, of course, a lot of our architectures are distributed. And so you have to think about how does this code run across potentially many machines in order to solve a problem. The fourth point is more expressive. So maybe it is more expressive. I don't know. And this was that earlier point, I think, made by Yashin. Hope I'm pronouncing that right, Yashin. That you working closer to, you are writing code that is closer to the problem domain more than the solution domain. So, and that speaks to the what. So, you know, your problem domain is generally a what problem, and your solution domain is more of a how. How am I solving this thing? What is the problem and how am I solving it? With functional programming, you feel like you're closer to that what. So you're writing code that's more about describing the problem rather than describing how you would solve the problem, if that makes sense. You almost let the language and the compiler solve the problem for you just through reduction, just reduce to the solution, if that makes sense. Like let the compiler figure out the best way to do this, which is an interesting and very broad point. But and so it's definitely not absolute, but it feels like you're closer to the problem. And maybe it's more fun. Like I would say I love the idea of continuous learning, right? So for me, when I use functional languages, I always feel like, geez, like I know nothing. I'm starting, these concepts are like, whereas when I jump into my old familiar languages like C, C++, C#, Java, even JavaScript, Python, where it's like, you know, these are simple languages, man. They're easy. There's not much to it, if that makes sense. Whereas functional languages often have got these like interesting wrapped up things around category theory, and like there's this whole like interesting academic environment around functional programming, which I always feel like for me is like, wow, it's so awesome. Like I'm learning so much as I go through it. And for me, like that's important. Like I think when you're writing code, who would want to get good at the language that they use and then use that for the rest of their lives? Like, no, not for me. Like for me, I'm always looking at like how can I improve my skills or know more about this domain or figure out better ways of solving stuff. And sometimes like don't limit yourself to the constraints of a single language or a single paradigm, right? If that makes sense. So these are some of my whys. I also put a why not, because there's absolutely like why not functional programming for sure. And these are just some of the ones I could think of. So like no side effects. So like, wow, if we can't write functions that change the state of the world or read the state of the world, like how useless is that, right? I write programs that want to do stuff, right? And if you're telling me I can't write to files or read files or talk to the network or talk to the internet or whatever, like that's pretty useless. That's like very limited to like the mathematical proof domain, right? And so, yes, yeah, functional programs, like pure functional programs, don't want side effects, but it's not entirely true. Of course they do. They just wrap them into a special holder for those side effects, which makes life more difficult for sure, but it isolates you from those changes. And we may look at something there. Like the second point, and this is probably the real reason that why not to use functional programming. And it's like, it's weird and uncomfortable, right? So we might look at some functional stuff later and you'll go, wow, like, geez, that's weird. And hopefully you don't, because maybe you haven't written enough code for your like brain neurons to like harden up too much, and you'll look at it and go like, no, actually, like this totally makes sense to me. But I think if you've written it, and for me, like I'd written 10 years of imperative code by the time I started to go, yeah, this sucks. Like, I think there's a better world out there. It was weird and uncomfortable in the beginning, for sure. Yeah, there's a big learning curve, absolutely. And sometimes that learning curve is not around the language itself, but sometimes it's those underlying patterns and constructs that sometimes are in the functional programming world are like a little bit academic. So category theory is, and things like monads and endofunctors and functors even, and monoids and semi-rings and semi-groups, like these are words that often are used to build up patterns in functional programming. And although I think you can be productive without knowing what is a monad, what is a monoid, what is a semi-ring, these kinds of things, it's like if you want to move into that mastery side, you kind of have to go there, if that makes sense. Whereas you don't really have these a sort of similarity in imperative languages. Maybe the most similar thing is like design patterns in imperative programming. Maybe things like the visitor pattern. And I'm not sure if you guys studied any design patterns at university or like aware of these things. I don't know. But maybe that's the kind of similar kind of thing in imperative is design patterns. So they're just different. And so the last point is like many others. There's like lots of good reasons to not want to use functional programming. One of the big ones is like skills, maybe, you know. So if you're working on a big project with a bunch of other people, and you wanted to do it in a functional programming language or write it very much in a functional way or whatever, one of the downsides is like you may not have friends on your team that support that idea, you know, because they have a particular skill set and they want to be productive, and so there's a learning curve that, you know, the entire team has to go through, etc., etc. I mean, there's many good reasons, but in my view, it's not, none of these are a good reason to not understand functional programming or understand some of the benefits that you can get from understanding functional programming. It's still absolutely worth going and learning and playing and figuring these things out, because those ideas completely transport themselves into almost every other language. And I think I've got like a kind of list of languages, and most languages today are becoming more and more functional. You'll totally see this. So it's not a like wasted exercise. You will be a better programmer if you can think about things in a functional way, even though you're using an imperative language, 100%. And we're all smart people. We're all like, you know, we've committed ourselves to a career of continuous learning. So like, brilliant. This is something. One of those cool topics. Oh, cool. Yeah. Okay. So here's a cool example of some code. And actually, like, we might live code some of this stuff to make it fixed. But can anyone see? So we've got code there on the left. This is JavaScript, and it doesn't really matter whether you know JavaScript or not. I don't really care. It looks like it's pretty simple to understand. And here's that file, stuff.json. So you can see it does like a read file sync of that file. Can anyone see a bug here?
I think the problem is going to be that stuff.json file.
Yeah.
What if that file does not exist? So what am I going to return back to the front? Like, what am I doing with it?
I like it. That's a good first bug. Any other bugs? No, I think I've got 4 bugs. I think I can see 4 bugs in here. So I can tell you when you run this code, it works. Yes. But like Yashin, I think it was you who said, what if the file doesn't exist? And that's very good. I would say that's a bug, right? Even though it does exist today, how do we know it doesn't exist tomorrow, right? So
and also
that's a bug.
That array, the records array inside data.
Yeah.
We don't know. Even right down to the attributes, the record.name for each one, for each object in that array.
Yeah. Exactly. Like, this code is terrible. So it probably works, but there's so many ways it can break, right? Because it's like so dependent on this file, right? So we can see, I don't know if I can point. Yes, I probably can point. So I can see, like, here's the first. Oh, I'm using the wrong tool. Let me use this. Check this. So there's like the first issue. What if that file doesn't exist? For sure. The second one is like, we're going like, here we're making a big assumption that like it's JSON, right? That it's in a JSON format. What if it's not JSON format, right? And we go JSON.parse contents. So like contents is just a string there, right? So we know that this thing will read like a buffer of the contents of the file. It doesn't make any assumptions about, you know, what is the format of it. It's just like a big string. So in JSON.parse, we pass it the string, but we hope that it comes back with like a JavaScript object there. Right? And what if it isn't JSON? So that's potentially another place it could break. Then your second point was like, we also make a huge assumption that the JSON that so even though it is JSON, how do we know that it's got an iteratable thing called records that we can for loop over? So that's a third assumption. And then the fourth one is like, we also make, for each of those records, we assume that there is a .name on that thing. And we know when we look at the file, we go, yeah, it's fine. It is fine. But we've made 4 huge assumptions here, all of which can lead to very interesting bugs. Yeah. So I think, yeah, okay, cool. So I made a little list, and these are those 4. So I'm not going to go through them again. Oh yeah, the last point was for bug number 4, that last assumption. What about the types? So here we're going console.log of something, and we're assuming it's a string. But what if it's an integer? Or what if records is actually an object and not an array? We can't loop through an object. Or what if records is a string? Or like it's broken like everywhere. It's like there's so many bugs, and all we've written is like 1, 2, 3, 4, 5 lines of code, and in fact we've got more than 5 bugs in those things, right? The only like non-buggy part is probably that first line where we say, hey, we're going to use the file system, and probably that could break too, actually, if we haven't got an npm install, or I don't know, if we have some dependency, who knows. So there's at least 4 bugs. So I think my next, oh yeah, okay, so I'm going to switch now. So let's try and write, let's try and like fix this code, right? And I need your help. So what am I going to do? I'm going to take control. I'm going to share my screen from here now. Okay, so you can see this Visual Studio code thingy here, right? Some code here.
Yes.
Yes, okay, good. All right, let's see if it actually works. So this is written in JavaScript, and if we go node example, I think it's just called example. It can't open this file, yes, because I moved it. I cleverly broke everything this morning. Yeah, there. Okay, cool. So that works. So what we've got is, so here's that original file, right? Stuff 0, and this was the same as that example we saw. And then I've created. So first of all, stuff1.json doesn't exist. So that's good. That's a good test. Stuff 2 has got bad JSON in that file. Stuff 3 has like put an exclamation mark there. Stuff 4 has like changed the type. So like here's a couple of good examples of like broken files that could. So we look at this code and we go, yeah, this is good code. Looks fine. Seems to work. But there's many ways that we've just talked about that they can potentially break it. So like how would we like write this more safe, I suppose? And so we're in JavaScript. So probably so we want to write a function, probably. I mean, this was my idea. It was like maybe we want a function called like read records, right, or something like that. And I suppose we want to write this in JavaScript properly. So I'm not sure if you guys are like JavaScript people, but there's a few different ways of doing it. You could write it like an arrow function like that, and maybe you want to say this is a const. So that's a function called read records, which is a function. But you could also write it like function read records, taking a file name, and maybe that's probably safer, right? So we'll go with that one. Well, it's not safer. It probably just looks a bit better. And so probably what we want to do is like let's lift these things up into this thing. So the first question that I've got for you here is, if this thing was strongly typed, and so if you consider that in C# or Java, you might say this is a function which returns like an array of record or something, read records file name, which is a string, right? So I'm trying to think of like what is the signature of this function read records, right? And so the answer is what? I mean, what should read records return? Any idea?
I would say it could return a string array, or in any array which you can use to build. You can build a constant every time and plug it inside. Or you can just
slower.
Okay, so I'm saying you can return a string array to get all the data inside the JSON file, assuming it does exist.
Yes.
I would say in TypeScript I could have done like return any array,
Yes.
and plug that inside. But yeah.
Yeah. And so I suppose that, I mean, of course, we could return whatever we want, right? It's JavaScript. And we could return strings sometimes and ints sometimes, and that's fine. It's all dynamic. But from a caller perspective, so a person making use of read records, right? What is he going to assume that he's getting? He's going to go const records equals read records from, this file or whatever. What do you think when he's reading this code, he thinks read records is going to return him, I suppose is the question.
A string array. Because you read
like
data.
an array of strings. Yeah,
Yeah.
yeah. So that would make sense. It would be these as strings, right? An array of strings. Yeah, totally. So I would say that like that seems fine. So I would go like, yeah, I think it's like a string array being returned by this thing, and then I would go let record of records their log record, something like that, right?
Mhm.
Set up. So thank you for joining this meeting. Obviously, thank you very much, Tom, again for your time. We really appreciate it and look forward to the session. Last time it was interrupted by some load shedding, but I think this session number 2 is, like I said in the invite, it's said to be a lot more mind-bending than even the first one was, which is a tough one, but it's going to be very interesting. So just to give everybody a recap on last time, maybe if you weren't on the call, we discussed essentially just looking at Tom's life story and his 20 years of working as a software developer, and just gave a bit of insight on some of the stuff that he worked on. Then we started looking at functional programming, just essentially why you would use it or why not, and did a bit of a comparison on functional versus imperative. And then we started having a test program to have a look at how the functional programming works. So essentially that was a file with 4 different JSON names where we wanted to add Batman to the end of them. And we had sort of a spot the mistake to see like 4 different issues that might occur or bugs that might arise from actually the way that it was currently set up, which was, I think, 5 lines of code and 4 bugs in it. And it was like essentially having the file is not existing, either or the data inside it is incorrect. Maybe it's JSON, maybe it's XML, some sort of other data structure. Could have been with the types. There's a lot of different things. So we essentially talked about that, and we were just set to actually make the program better and essentially write it in a more functional way with some pure functions, and then electricity outage hit us. And yeah, so actually the sad part is that it ended it with a very bad dad joke. So thank you for that, Noel Loxton. We really appreciate it. Yeah, so actually, yeah,
Awesome.
just a mention that this meeting will be recorded. So there's a few people that said they wouldn't be able to attend. So we're just recording it, and we're gonna maybe share it later for them, or maybe upload it on the SharePoint or something.
Yeah.
So yeah, without any further ado, Tom, you can take us away.
Yes, that's awesome, man. Thanks, Arno. I missed the dad joke, unfortunately. Oh, because I had no power. But my power's back. And you said we're going to make the program better. I think we're going to make it worse first, before we maybe make it better. But let's see how we go. So, wait, I've got to share my screen. Let's just do that. There we go. And hopefully that is visible. Yeah?
Yeah, yes.
We can see, yes.
Oh, yay. Okay, good. All right, let's hope for less issues than last time. So I'm just going to dive right in. Arno, great summary. Thank you for catching us up. And maybe I thought we could maybe, I've got the first video, the first part of the video, and now we'll make a second part. Maybe we'll glue them together. Anyway, okay, so we were doing this. So we said, cool, we had an earlier version, which we now destroyed. So we don't remember what it looks like, but effectively, we are wanting to improve our 5 lines of code which was full of bugs, right? And so what we're going to do, I think, is like extract it into like a function called read records. We pass a file name to that function. It kind of makes sense, and we want it to kind of give us back the contents of this file, possibly as like an array of strings of people's names. Like that totally makes sense. We said, although this is JavaScript, let's pretend it isn't. It's still a good idea to think about, even when you're writing a function in JavaScript, to think about that function's like its signature, like what contract does it offer, I suppose, to people using it, right? So when there's a huge separation between the stuff happening up here, above here, in this is kind of like library code, down to here, which is where you know, this is somebody making use of that library, right? And it could be, although luckily, you know, we're in a single file and I'm kind of one person, but you could imagine that this is a different person doing this to the person who's writing that up there. In fact, it could even be that, you know, this could be someone sitting on the other side of the world, you know, who speaks a different language, speaks German, whereas this is a person sitting in South Africa who speaks English, and they're making use of it. So it's always it's a good idea in your mind when you're writing functions or generally code is to write it for someone else, even though it may be primarily you using it. It just kind of gets you in a good habit of writing better code, right? And also, like, you know, from a temporal perspective, I may write this today and in 10 years may want to use it, right? And like my memory is totally gone, and in fact I'm a completely different person. And so what I was thinking at the time when I wrote this is, you know, potentially completely gone. So it's important to think about functions with their signatures. And some, you know, strongly typed languages would enforce that. JavaScript doesn't, but it's still important, right? Okay, so we're saying, cool, it's going to return a list of strings. So here we go, right? So I suppose we could, you know, let's just lift this up here. And I suppose we could just say, like, we're going to write it naively first. And we're going to go something like a var, maybe, results equals an array, maybe. And then for record of records, I suppose we could go results dot, I think it's push. Yeah, makes sense. Record dot name, correct? Something like that. And then return results. Yeah. I don't really care if we, you know, like I don't think we're ever going to write this, run it actually to see if it actually works. Who really cares? But I think that's probably right. I don't think we've improved anything about like the issues that we had earlier, which was, you know, the file not existing, it not being JSON, it not having, oh yeah, this should be like data dot records, right? Not having that records thing as a capital. No, it's a lowercase thing. And name also looks like it's a lowercase thing. And not having those fields, right? So we haven't improved anything. So we've just kind of made it, we've just hidden it away in a little function. So maybe the first thing we want to do is like, let's deal with that first one, like the file not existing, right? So let's do that. So we go, so we know that when the file doesn't exist, oh yeah, there's another issue there. File name should be passed there. Is so maybe we do want to run it actually, so we can see the exception happening. Let me just open my terminal. Intro to FP. Where were we? Live node, and we go node example, and it says no such file or directory. I wonder why. Don't want this stuff. Not so that's a good thing. Anyone see our issue here? Stuff is 2 directories back, I think. Oh, maybe I didn't save it. Yeah, okay, I didn't save it. So if we made that stuff 1, which doesn't exist, as you can see here, we run it, we can see, okay, cool. So it throws some kind of error with some kind of text. So we've got to be able to sort of handle that, right? So how do we do that? We catch an exception, right? So not 100% certain how to do this, but let's try. I think it would be try, probably catch. This is probably just catch some kind of error, or maybe we should say exception or EX or something. Because there's no typing here, we just kind of have to catch everything, I suppose. And now the interesting question is like, okay, well, if that happens, what do we do, right? So I suppose we could initially just go, just see that it happens, caught an exception, and we go plus exception. We just hope that it can print a string, and we'll like return. That makes sense. Yeah, okay, cool. So we are able to caught an exception. That's good. So that's fine. What should we do in this scenario? Does anyone have any ideas?
I would have taken out that try and catch block, created a new variable of type var, called it say new file, point to that path, so 2 directories back stuff, whatever the file name is, and then I'll say if that file, my variable, let's say I said var my file equals to new file, and then I pointed it to some path, and then I said if my file dot exists, proceed with the code, else then I can send out an alert to front saying file doesn't exist.
But haven't we just done that? I mean, we know that the file doesn't exist here, right? File doesn't exist, right? Agree? We're in that place. So what should we do? I mean, whether we check that the file exists beforehand or not, we know now that the file doesn't exist in this piece of code, in this block, right?
Mm-hmm.
So what should we do from a function perspective? What makes sense? So I mean, one of the ideas would be maybe like, we know at this point, like return an empty array, right? Maybe that makes sense because we did promise people that we'd be returning them an array of strings, right? That's kind of what we said from a function perspective. From a signature perspective, we are promising a set of strings. Whereas if we had to say, actually like return null, maybe another option, or we could do something else. I don't know. Or we could raise. I don't know if we can. How do we raise? We throw. We could log it and then rethrow it potentially for the poor guy down here to handle. So the point is like, what makes the most logical sense to do here? And I'm saying there's not necessarily one good answer here, or one correct answer. But what would be the least surprising thing to do here? Is it a tough one, or am I?
I think the return of the empty string. I think the return of the empty string, because the user on the other end is expecting an array. So even if the string array is empty, at least they get the same data type back.
Yeah, so that absolutely. So that's like one possibility. One option is return empty array, which I'm not like, I wouldn't be too unhappy with, because we are now sticking to our guns. Another option absolutely is to say, second option is to throw that exception, right? To allow that exception to like bubble up to the caller, because so we can throw up our hands and say like, we don't know what to do with the file does not exist exception. Like, we don't know how to handle this exception. So let's raise it up and hope that someone further up our call stack knows what to do with it, right? So that's certainly another option, is like, just let it raise itself up and put the burden on this poor guy over here to handle that exception, if that makes sense, right? That's the second option. They have pros and cons to them. You know, the pro of option one, and I think there's just variations of these two actually. Option one is a nice one because what it means is that the burden is not on the caller. So here's your caller down here. This is your caller, and this is like your callee or your library. The placing the burden on the caller is not always a good idea, and the reason why is because he kind of just sees this, right? So nothing up here tells him clearly that, you know, there could be something else that happens, right? So when I read this function, read records given a file name of string, I'm expecting to get back an array of strings, right? Nothing here tells me that, oh yeah, also you could also get this like nasty exception coming at you that you're not prepared for. You know what I mean? Some languages do that. So like Java, for example, adds this cool thing here, which is throws, you know, whatever file not found exception. And that's really cool because when I look at this, I go, oh yes, okay, so I can get these strings, but I also am aware that, you know, it could throw this kind of exception, and the compiler can even check that you handle this, which is pretty cool. But most languages don't really do that, and so exceptions can often come at you from kind of anywhere. And so my view is like, try to minimize that, because I think exceptions are are generally very surprising, unless you write a big thingy up here. Oh yes, also important that you handle an exception. right? Add it into the documentation or something. But as we all know, like there's probably a smaller percentage of people who will read that. Okay, so let's return the empty array. So from a downside perspective, so that's a nice thing because it keeps this clean. From a downside perspective, the nasty thing about this is that we're like throwing away information, right? And that information is that actually something went wrong underneath. It's not that it went right and that it was an empty, for example, if I took this and it had no records, if it looked like that, that would also return an empty array down here, right? And so it could be assumed that, oh, look, the file's just got no records in it, so we're good. As opposed to, oh, look, the file didn't exist actually, and that's like a bigger problem. And so that's the downside. So that's the downside of keeping it clean, right? But anyway, let's keep going. Let's go with that one, and we'll solve that problem potentially in a different way. So let's keep that throwing away information. Okay, so that looks a bit better. We can now handle the exception, and then down here we're going to pause it. And now already what I'm starting to see is like, oh, look, I'm not sure if you guys can see the issue here yet. But is this code going to just work? Probably not, no. And it's because of that, contents, right? So what is our issue here? So it's saying contents is not defined. Any ideas why that is?
Isn't it out of scope?
Yes, it's out of scope, exactly. So already like, okay, cool. So we got clever and we said, let's handle this exception. Now we're also having to go, oh yeah, so this thing creates some scope. So the scope of contents is within this little scope blocky here. So again, we've got like two options, right? So we can lift this thing up and we can pop it in there. And now we're starting to say, oh, look, our exception handling is now like for exceptions of both types, right? Because we also know that this could potentially throw an exception. And it's going to be caught by the same exception handler, I suppose, over here. The other option is to say, well, we want to keep them separate. And we want to have a second try catch block over here. Try catch whatever. And now we have to deal with the fact that we want to lift that thingy out into a higher level scope. So probably we want it up here. Contents equals, I don't know, something. And make that not a new variable. Contents is probably a string, so we want it to be like an empty string. Problematic though, because we're like reassigning it here, and so it can't be a const anymore, right? It needs to be a variable. And so like the reason for having const there was like quite a nice one, but now we can't have it. Exception there. And now maybe we've got a different way of handling the second type of exception, right? Does that kind of make sense? And now, yeah, of course. So like we have that same problem again over here now, where it's like it wants to run through data. Guess what data is in the scope of this thing? So it's like, okay, already we're going, oh yeah, this is like this lifting into a second try catch block. It's probably going to hurt us because once again, it wants var data as something, and we're going to reassign it there, and it's no longer a const, etc., etc., etc. Right? So this is probably a bad rabbit hole. So let's stick with our first one, which was like, cool, let's keep it a const. We were happy with that. This thing can be a const. And we can already see that like we know this is going to happen again. So we're going to put that there. And life. Yeah, okay, so yeah, file doesn't exist, or file isn't JSON, or records don't exist, or doesn't have a .name attribute. Right, so there's many reasons potentially that this exception could be raised now, right? Because like kind of any problem over here could raise this kind of exception, right? But at least our code works again, which is great. I suppose we could test it through stuff 1, see what happens, and it's like, oh, cool. So stuff 1 doesn't exist, so it's an empty list there. So nobody's Batman, right? So that's cool. Well, is it cool? I would say probably not that cool. Number 2 was, oh yeah, we broke the JSON. So also nobody's Batman. I don't know. They're definitely throwing away information there. 3 was we were missing that field there. So again, nobody is Batman. And number 4, oh, 1, 2, 3, 4. Oh yeah. So what did we do with 4? Oh yes, we made them like kind of ints. We like changed their types or whatever. I don't know. I mean, like whether that's a good idea is I'm not sure. But anyway, like what we've so maybe we've made the code like less runtime brittle, but I wouldn't say that we've made this much better. What would you guys say? I would say like, wouldn't it be nice if the caller down over here knew that something was broken, right? And so this leads to saying, well, actually, is this type here as a return type of string array, is that actually appropriate? Like, are we allowing enough space to encode these different kinds of scenarios that could come back? Because if you think about it, like actually maybe what we want is like we've got a few different situations when we call read records. Of course, the one is like, yes, we were successful, A second one could be like, actually, the file you provided does not exist. And it's like, actually, remember the file you provided, because you did provide that file, right? And so probably as a caller of this thing, I would like to know if the file I provided there does not exist, right? And then there's others, like the file, isn't JSON format. That's interesting, I think. And the second one was like, maybe there was an empty set of records. And actually, maybe that's encoded in success. So it's like, we want to know that when it's successful, I want an array of ints. When the file you provided does not exist, that's actually fine. I don't need any other information included with that error. The file isn't JSON format, probably also makes sense to not give me any other information. But what about like the field records I don't know, is broken, or like some kind of parse issue, right? Yeah, like a parsing error. And actually maybe I do want to know, that the exception was like let's actually go and have a look. So if we go console.log exception here, and we run this on number 2, like let's run it on this balked file here, right? Which was number 2. I'll just comment that out. Number 2. I'm sure we're getting some information from the exception. Yeah, you can see it here. So when we catch that stuff 2, I'll just put it up. When we say parse that please as JSON, actually the exception does carry a bit of information. It says unexpected token B in JSON at position 0. So it's saying, hey, like I was trying to read JSON and like B is definitely not the start of a JSON packet. Like a JSON file either starts with an open curly bracket, or I think it could start with an open square bracket if it was an array, or it could start with an open quote because it may be a string, or it could be an int. It could be some kind of JSON primitive type, but B certainly is not, is of no type I'm aware of. So that actually is quite interesting. So when we get a parse issue with isn't JSON format, actually maybe empty is not right. I actually would like to see the particular error, right? Particular error, because that might be useful. Sorry, I think I went on and off for a minute there. Can you guys still hear me? Yes.
Yes, you can.
Oh, okay, good.
Yes.
Okay, cool. Does that kind of make sense? So like we want to maybe carry some additional information. I wonder if with like this guy, what we would get. So stuff 3, let's try run that and see what the exception looks like. Is there one? Oh yes, data.records is not iterable. Like that's also very cool. So there's some other kind of issue here, like I don't know what we'd call it, like a structure issue, right? And on that, I would also like to know the particular error, like data.records is not iterable. Does that make sense? So actually, when we think about this function read records, we've placed a pretty big burden on, a pretty big set of requirements on it, that yes, in general, it should do this, but also sometimes we'd like it to do that and to do this and to have that, right? There's different, and so string array up here is like, it's not enough. We're throwing away that information here by just saying returning empty string. So any ideas as to how we could make this function better? Given these requirements?
I'm not quite sure on what we should return because I'm still thinking of it there. But I'm thinking the approach that I said with checking the if statement first, if this file exists, and then I can return an inappropriate message to the front. Then going on to check, is the first character in the file so let's say the ASCII value of the first character, is it a valid one? So the four you mentioned, the caret, the array bracket, the apostrophe, and the number, is that valid? And then from there, I can use the has own property to see if this JSON structure that now we passed the first two if statements, it is a file, it is a JSON structure. Is this structure with the inappropriate property, does it have the property of records? And inside the property of records, does it have the property of name?
Yeah, no, I totally hear you. We can run those checks for sure. I'm saying to you, like, don't bother. You're already catching an exception here, and we could know that, like, this particular one is like a type error, right? So we earlier had a syntax error. Here I think we get a reference error. Here we get an error. Well, so let's separate those two things. So I think you can go if exception, is it instance of? Yeah, instance of error. Now we know it is a file not found type error. Versus, I suppose we go else if over there. I don't know, probably here. Else if exception instance of. I'm just being more lazy than what you're proposing. Sorry, instance of type error. So type error tells us, okay, that's that scenario. I wanted to get that parsey one. Reference error, no. Records not iterable, no. Not that guy. Oh, maybe it was below. It was that balked one, right? Yeah, syntax error. It was that one. Now we know it is a JSON parse issue, right? And let's just go big else there. So the question is now, so otherwise, I don't know, something else. What are you proposing that we still return a blanky thing here, or you were saying you wanted to notify this caller somehow of the error? So how do you propose doing that when the only way of notifying him is through this array of strings? Are you saying return file does not exist like that? Because that would be weird if records were set to now a string. Or are you saying let's log it and hope he looks at the console? Console.log file does not exist, and then return a thing, or just return nothing here? Or how do you propose informing the caller that his file does not exist? That's kind of what I was asking. Not how to handle it. I think there's many ways of how to detect if the file doesn't exist. That's totally fine. How do we tell the caller down here that his file does not exist? Given that the only way we can communicate with him is through the return value or raising an exception to him, which I think we're saying, like, let's forget that particular one. Yes, someone else?
Can we not maybe write the error message into the first item of the array and then just maybe prefix it with error or something?
Yes. Okay, so that's definitely one interesting direction that you're going. So I quite like that, actually. So potentially what you're saying is, like, when we return this okie, like whatever we return on this side, maybe there's like an error part as well as like a success part, right? And he can check for this error part kind of first. if that kind of makes sense. So, and probably the way with JavaScript to do that is like you make that whole thing an array, right?
Yeah.
I think that's sort of what you're saying. So, okay, well, so I don't think that's a bad start. So let's go there. So given now this signature, read records now can return an error, an error and a thingy. Let's just paste that down here. So we know that this would be our, I don't know if JavaScript will destructure like this. Maybe it would. Error equals something like that. I think it would. So we can now say like, oh yes, so in this scenario, hey dude, your file does not exist, and actually I'm going to give you back an empty list of things, right? Sorry, that should say return. And the same here. This is like pause error or something. And maybe let's be cool by giving him the exception text over there, right? Pause error. Everything else is like unknown error for now. We're not sure, but there could be other kinds of errors for now, right? So maybe we should go plus exception, right? So that way, and okay, so then in our successful case, we want to return like null, there was no error, and here's your list of results. Happy with that? I think that that's not a bad first stab actually, because now we are kind of saying to the dude like, oh, check, there could be errors. So when he reads his signature, he goes, yeah, I can get my string of thingies here, but also I should be careful of errors there. And then he is kind of forced. So I suppose he could still just do this, right? He could just do this, run his code, and stuff may break, or he may assume that that it's empty Batman's, but at least he could check like if error, then whatever, do stuff with that error, else print his, like everything was good, and print my Batman's, right? Does that kind of make sense? I'm not sure whether this will actually work, and do we even care if it works? We're just trying to illustrate the kind of the point. Maybe it actually does work. Let's go console.log error, right? Yeah, file does not exist. So that's pretty cool. Check, we wrote good code, yeah. So I think that this is certainly improved stuff. I'm not sure if this kind of idea, are there any JavaScript programmers out there? This kind of pattern may look recognizable in other places. So often in JavaScript, there's this concept of callbacks, right? To provide you data. And often callbacks have this kind of signature where the first parameter to the callback is like a potential error, and the other, and then subsequent parameters are like the successful cases. And it leads to a whole lot of code that looks like this, checking the error, if that kind of makes sense. So anyway, like this is certainly one good idea. The kind of problem I would point out here though is that, and this is unfortunately the truth about JavaScript and actually a lot of languages, is we have a data structure here, and whether it's an array or whether it's an object, because you could also say, hey, like why don't we make this an object? It would make it maybe more explicit. We could return potentially, well, let's actually just write it like this is maybe what it looks like, but it's like error with an error, the actual string, or it could be null, right? So if we think about its types, otherwise the results, which could be, a string array, or potentially null actually if there is an error, because maybe when things are successful, maybe we'd choose to go null there. I don't know. And that way, at least we would hurt the person calling it if he just tried to iterate over it, right? So if he called this thing and this thing was null, he is kind of forced to check for the error before he just iterates through them and assumes that they're okay. And I would say, yeah, I don't know if I'm happy with that. I prefer not to hurt the callers. I prefer to force them to handle errors anyway. But if you think about the types, it's kind of this, right? So we're building the return type to this function is like this object which can have kind of two different states, either this error type state or this like successful type state, right? And unfortunately, with the data structures we have in JavaScript, either an array or an object, it's always both of them. Does that make sense? There's no real primitive way of saying this is an or type relationship. Does that make sense? Like I want an error or I want a success. I don't want both and I don't want none. You know what I mean? Because if I think about like what is acceptable here, I would be okay that error is set to null and success is set to some array of stuff, right? That one is okay. Error being set to something, some string, and success being null or empty, like that's also okay, and that's expected. However, there's a situation here which is like a weird one, which would be, hey, error is null and success is null. This is like not okay, right? I'm not okay with that. And I'm not, and I don't want my caller to have to deal with this situation. The other one is like where error is something and success is something. Success has got stuff in it. This is also not okay, right? This is a scenario that I don't want to support, but yet I am. So when I write this sort of function signature, I can't encode that into this to say, yeah, it's an error or it's a string. Does that make sense? It's always both. So what we have here is we have an and relationship. Does that make sense? So objects and arrays certainly are both and type things. It's all the elements, right? And so often this is called a product type. So it's a product type, which means it has to have both. It has an error and it has a success. Of course, we can set it to null, but it's still there. And null is an absolutely first-class value, right, for error. This is getting a little bit theoretical, but I think it's good to know. So knowing about product types or and types, this is what most languages like C#, Java, JavaScript, C and C++, etc. They all primarily use and product types. There's no natural or type. You may say that. So there may be though. So like in C, you have this concept of a thing called a union. You have a thing called an enumeration. And these things are starting to be OR types. So enumeration or a union is an OR type where you can encode here. I could say somehow in the encoding of this, I could say it's an error or it's a string. It's not both and it's not none. So it can't be these two scenarios, meaning that my caller can be very explicit about can explicitly know what my return types are. Does that kind of make sense? So these are OR types. They're also called sum types in more mathematical senses. So you have products. So if you think about like what does product mean? Product means multiply, right? That's a product, right? So product is 1 times 2, and the sum would be 1 plus 2, right? And so why are they called sum and product types? And for me, it's very simple. It's like let's just work out the combinations of a product type. So if you look at this, you can see that this is a permutation. And so how many permutations are there? There's kind of 4 permutations. So it's like there were 2 potential values for error. It's null or string. Success has got either null or an array. So that's 2 times by 2. There are 4 permutations. What we really wanted was we wanted a sum type where we say we only want these 2. So we want 1 permutation plus 1 permutation, meaning we've got 2 possible states. So often when we and apologies getting too theoretical, but it's cool to know this kind of stuff, to look for in a language, look for their concept of what is a sum type, and that can sometimes give you a good way of writing more explicit stuff here. So unfortunately in JavaScript there's no such thing really. I mean, you can kind of make up your own sum type, I suppose. There's no real native one. So maybe one way of achieving it though is to say, well, okay, so our return type here, we can't encode enough into this thing. So is there another place where we could encode more stuff into this function? And yes, there is. And so this might be like a little bit surprising, but because this is JavaScript supports first-class functions, we could pass a function in here from like a callback perspective, which would then allow us to encode a particular thing. And so what I'll go through it quickly, and we'll just quickly implement it, and then explain it later. But let's do this actually. So what we want to do is if the file doesn't exist, we want to notify this guy down here that his file doesn't exist. So effectively, we're going to do it like, let me just rewrite this actually, and then maybe it'll be more explicit. So we don't like any of this. This is all broken. It's not broken, but it's too simple. So effectively, what we want to do with our JavaScript is we want to say, yes, we want to give you this thingy here. But what we want to know is if the file doesn't exist, then, and I think we go like this, please call this function. So we're going to pass callbacks into our read records function, which is going to encode us and give us more information about the scenario that didn't work. Parse error equals a function with the particular error, because we wanted to carry that, or the results is a function with results with the actual results. So here we can see already, like, look, we're kind of forcing the caller to handle the 3 different situations that could occur. So we know that when it's results, we want to do that. When it's a parse error, we want to actually print the error. And when it's a file not found error, file not found, there's nothing. Like we have no information given to us other than file not found error. Whereas up here, if you think about at this point, we actually did have that information. We had the exception, but we didn't plus it onto our string, if you look there, because we didn't really care. Like, if the file doesn't exist, there's no other information we want to tell the guy, just his file doesn't exist. That totally makes sense. Whereas if it's a parse error, we want to pass him that particular error so that he can print it out. But these are 2 different scenarios, right? And here we've already encoded them. So we said file doesn't exist, carries no information. Parse error carries the particular parse issue, which he can then print. Whereas with results, he gets a list of string, which he can print over here. Does that kind of make sense? So we can go ahead quickly and implement this. And really what we're saying is we're going to take these extra thingies as parameters. So these are now first class functions. If that makes sense. And we can say, hey, when we're down here in exception land and we know the file doesn't exist, we can just execute that function. File doesn't exist. When it's a parse error, we execute it with that particular message. And when there are results, we don't do this. We don't return them. We just return, this is called results, and so is that called results. So let's call this, I would call it prime, but let's call it results underscore. Return those results as a function. That kind of makes sense. Oh, and if there's like an unknown type error, there's a third scenario that we're not supporting, which is an unknown error function, and it's like, I don't know, the actual text of it. Yeah, so why not? Yeah, the error description, that's fine. And it's similar to that one, right? I'll just go unknown with that error. That means we need this guy up here. What do you guys think? Look, we've written a better function, haven't we? And I think yeah, look, so we've done it nicely. So if it's stuff 0, file not found, did I save it? No, why is that stuff 0? He does work. So we should probably be printing here just for debuggy reasons. Records is not defined. Ah, yes, okay. Oh, so look, records not defined is also of type error, what's being handled up here. So how irritating is that actually? So in fact, maybe we don't even have like, I don't even know how you do this. So like, maybe we have to go if exception instance of reference error. Now we know, and this would be an else. So now we know records is not defined, which is that scenario What scenario was that actually? Oh, in 0. What did we do with 0? Records is not defined. Oh, I don't know. Let's make this an unknown error. Yes, unknown error. Fine. Okay. Well, I don't know. So there's some issue here, right? Maybe you guys can see it. Can you see it? Do we care? Records is not defined there. I don't know. I didn't even want to run it actually, but I wanted to demonstrate the idea of now. So in fact, now if we look at our signature, we no longer return actually anything, but we now return a whole lot more information up here about the 3 different scenarios, or the 4 different scenarios that could occur, which are now actually, if you think about read records, this has actually now become something which does support. It's more like a sum type or an OR type of function. So this function, either it executes this part, or it does this part, or it does this part, or it does that part, right? There's no longer any doubt as to, like, sometimes it's a this and sometimes it's a this. Do you know what I mean? There's no decision that has to be made by the caller. Does anyone have any questions about that? Or does this look very foreign? Is this very weird? Or does it seem okay? Somebody's unmuted, so you can
I
talk.
think it seems okay, yeah.
Okay, yeah. And so you'll see this a lot in JavaScript. Definitely this kind of idea of passing callbacks into functions in JavaScript. Often it happens around, like, I want to, like file reading, or I want to make a request over the network. But often you will see like almost no use of the return value, because in fact the return value here is nothing, right? In fact, we have no return statement in this function whatsoever, right? There's no word return. So in fact, we are always returning like undefined. It's like always undefined. So in fact, we've just thrown away the idea that this is a function which returns anything. It's like it's a sum type function, because it will just execute the right chain up here. So quite often this kind of pattern, I would often call this like a continuation type pattern. And and why it's called a continuation is because I execute a function which then is going to execute a function for me in order to continue the computation that goes. So I'm not saying this is perfect, because if you think about it, like, now if you're going to do a whole ton of stuff based on what results does, it means like all of your code, from here on in is like squashed into this little thing. And if you call another function, that does something similar, and it also takes results which also does more stuff, it's like, oh look, we're starting to nest sort of left to right, like our code opens and opens and opens and opens and opens and opens, right? Does that make sense? So this kind of idea tends to shift your code from like top to bottom type of stuff to more left to right type stuff, because it's embedding scope inside scope. Does that kind of make sense? So I've done that very ugly, but hopefully it passes it on. And that quite often is called, this kind of idea is called callback hell, which you might have heard about. And if you write enough JavaScript, you'll certainly experience callback hell. And so there are different techniques in order to manage callback hell, right? So it's a good idea overall, this kind of thing. It's a good idea, but it's not quite just as simple as this. So to live with this is very hard. And so things like promises and observables, etc., exist in order to take this very left to right code and turn it back into top to bottom type code. So promises and observables will do that, but I'm not going to get into that kind of stuff. So it's definitely worth getting into that kind of thing. Anything else? Any other questions? Because I think we're done with this example. I think we've butchered it. It's a horrible looking function though, hey? Are we happy now?
I have a question.
Yeah.
Is this sort of I don't know if is this something specific to like functional programming, or is this just like good practice generally?
Yeah, that's a good question. Now, I would say this has got very little to do with functional programming, other than functional programming. Functional languages often have support for a sum type. And okay, so I'll show you an example actually. So I've got this exact thing, I think, written in PureScript. So PureScript is a pure functional language. And I've written a function called read records. I'm not going to take you through the syntax. It's very scary. It could potentially be very scary. Looks very different. No brackets, indentation is very important, that kind of stuff. But one interesting thing I can tell you about the PureScript version is it does make use of the return type. So if we look at what read records does in PureScript, it takes a string and this is what it returns. So it returns, you can ignore this thing called effect, takes a string and it returns a read records result. That's its data type. So it's no longer an array of strings or whatever it is. If we look at what is a read records result, we can see it's this thing. It is either a file error or a parse error, which carries a string, or a got records with an array of strings. So this could be like success, I suppose. In our example, I think we called it success. So what PureScript does as a, and it is a particular dialect, of a language, very much inspired by Haskell, is it has first-class support for that idea of sum type. So it says read records results could be a file error or a parse error or a success. It can't be all three of them. It certainly cannot be more than one. It has to be exactly one. And in fact, if it's a parse error, it also must carry around a string. If it's a success, it must carry around an array of string. Does that make sense? So these are called constructors of that type. So the cool thing about this is it's very explicit, right? It's very explicit. And so when I call read records down here, wherever it is, there, read records, and I get the results back, I have to say, like, I can't use it because I don't know what type it is yet. I have to do a case match on it and say, oh, it's a file error, then do this. Oh, it's a parse error. Please set the string that it was attached to this variable called error, and I can do something with it. If it was a got records, I got an R, and maybe I want to show those records or whatever it is. So a pure functional languages very often, well, certainly like PureScript and Haskell have very strong support for this notion of a sum type, which is like I find in a lot of like not explicitly functional languages are like glaringly missing this kind of idea, this sum type. You can of course do it through things like this, but it becomes quite wordy and quite annoying. And it's not also a guarantee. So for example, here where I catch an unknown exception, an unknown error, I could also call like parse error at the same time, right? I could call that, then call that. And what I've done is I've ended up calling this Oki's function there and then his error there. And it's like, oof, he probably he very much didn't expect me to do that, right? He expects me to call at least one of these things. Well, not at least one, exactly one. So not 0 and not more than, and not 2, right? But I'm not prevented from breaking that error up here. In fact, I don't have to call anything. So in fact, if I had a bug in my code and I left off this else over here, I would end up calling absolutely nothing down here in that scenario. And I would leave his program just sitting there, right? It would just be doing nothing, right? And that's a very unexpected state for him to be in, right? That he calls my function and then suddenly nothing occurs ever again, right? It gets kind of just lost in this, or the program exits or whatever. Does that make sense? So when you ask, is it a functional thing? I would say the idea of a sum type is certainly something that's popular in functional languages, but it doesn't mean that you can't use them in non-functional languages. Like here, I've just demonstrated that we could have a sum type idea. Does that make sense? Yeah. So here it's pretty explicit. Okay. All good. Okay, so what I'm going to
Yes.
do is, yeah, shoot.
No, it's all good.
Okay, cool. I'm just going to go back to my iPad here. So I think we've got 30 minutes, and I think, yeah, cool. Hopefully, oh yeah, I'm going to stop sharing there. Okay, there we go. Cool. All right, you guys can see that, right? Yeah.
Yeah.
Okay, so I know so one of the things about functional programming, and maybe I'll talk about this very briefly. I won't give any code examples, but we talked earlier about side effects. Did we talk about side effects? I think so. So I said I think we talked about this idea of purity in our program, right? So in a pure functional language, we have no ability to create side effects. Which means we can't read a file and we can't write to a file. We can't talk to the network because these are things that are outside of the purity of our program, right? If we assume that our program is kind of like a mathematical sort of set of expressions or whatever, an expression can't like read a file because that file might change tomorrow or it could change the next second or whatever, and we know that when we execute a function with a particular input, it must always give us back that same the same output for the same input, right? So if I give +1 a 1, I expect it to give me a 2 in all situations, right? It doesn't matter what time of day, what like planet I'm on. +1 + 1 equals 2 always, right? And that's one of the cool properties of pure. Pure means and when something is pure, you can have some interesting effects. Like for example, if someone says what is 1 + 1 and I give them the answer 2, someone else asks what is 1 + 1. I don't need to recalculate it. I already know it's 2 because I gave it to someone else earlier, right? I don't need to recalculate it. So for example, like calculating pi to 1,000 decimal points. If someone executes that twice, I can just remember, like for pi 1,000, it was this answer. I don't need to go and recalculate pi to get to it again, right? And because it's a pure function, I know that it's not possible that it could be different, right? Whereas if I was reading pi, like the starting point of pi off of disk, I have no such guarantee that it's still the same in that file, right? Some external factor is an input to that function. And so it's not entirely true that something like PureScript or Haskell has no side effects, because it would be pretty useless, right? To write a program that has no effect on the world. Like I can't think of one situation where that would be useful, other than maybe I was a mathematician, right, and I wanted to solve pi, right? But even at the end, if I know what the 1,000th decimal of pi is, I probably want to print it, or I want to like show it to the user. And if you're saying showing that to the user is a side effect, like sure, that makes it a pretty useless function that only the program can have the answer and no one else, right? And so of course the no side effects is not really a thing. What happens in functional languages, they're often just put inside a box. And so you have this pure side of your program and you have this impure side of your program. And that impure side is very much what it does is just open the box, and it's for like one small situation where effects are going to occur inside this box. And the idea is kind of that what you do on the pure side is you do a whole lot of preparing yourself and putting stuff into that box while your program executes. So if you were calculating pi, for example, and you were reading the starting value out of a file, I don't even know how to calculate pi actually, so maybe a bad example, but like, but say for example, you needed a starting value that you were then going to like iteratively calculate pi on or something, and you needed that out of a file. What you would do instead of reading it out of the file in your program is you would say, hey, my program needs to read this out of the program, and it will give me a result. With that result, I intend to do the following. So it's almost like I'm going to wrap it up almost as like as a declaration. So the reading of that value is not something your program can have directly in your code, but it's like you can think about it notionally. Like if I know that the value is of this type int or of this type float or whatever it is, or potentially the file doesn't exist, here's what I should do. Here's the continuation down the different paths. And my program is more about describing what are those paths that it should take. And then when I execute my program, what happens is the the kind of like the runtime sets up that whole set of expressions all in your pure code, and then it opens the box and it says, cool, let's go wild, right? Let's execute it. But it's kind of no longer your code that's running explicitly. It's kind of like, if that sort of makes sense. I mean, it's like a weird example, and we have to go into it like into a ton of detail. But it's this idea of putting your effects or your impure code inside this box, and then you can still reason about what's in that box. So you may know that this box, when it's opened, may have an integer for me, or it may have an error. And if it does, I can add more stuff into that box. Say, oh, if it's an error, then I want you to do this, and I put that into the box. And if I get an integer, then do this, and I put that into the box. And if you think about it, that's my code, right? My code is just putting stuff into this box. And then at the end, I just say, hey, here's a box. And I just return that back to the impure side of the program, and the impure side goes, cool, I'm going to open the box. So, let's hope that it works. And that's kind of the idea of the way I certainly think about how side effects work in a pure language, is this kind of box concept. And then there's a whole bunch of like really cool ways of describing different kinds of boxes, different ways I can like combine boxes together, et cetera, et cetera, et cetera. And this takes you into this very exciting world of things like monads, monoids, functors, applicatives, et cetera, et cetera, et cetera. It's like a whole world of things about what can I, if say I've got a box and a box, right? I've got a box that opens a file, and then a box that displays this thing to the console, displays an integer to a console. These are two boxes. I can't give my program back both boxes. I can only give him one box to open, right? My program can only open one box. I've got a function that can say, do this, and when I get the int out of this file, I want you to run the print the int function that's inside this box. And I can compose these boxes together to create a new box, which is a composition of these two boxes. Do you know what I mean? And I pass that box back to my program. So like a way of composing boxes together. Does that kind of make sense? It sounds pretty wacky, but it really is like that, actually. Any idea? Has anyone ever written any pure functional code? No. You should. Someone has. Rudo. Tell us, Rudo.
Well, no, I mean, I think a couple of us have, certainly those who did comp sci at the University of Pretoria. We did,
yeah,
again, the basic stuff, but in scheme. I guess that is pure functional.
Is it pure functional, actually? Yeah, I think it is. Yeah.
My comment is like, yeah, it's for all the compile optimizations, the only real control structures you have are recursion. So I don't know how efficient functional programming really is, but maybe I'll just have a bias. And anyhow, that's my comment.
Yeah. Okay. Yeah. So it's a very good question. Yeah, that's one of the first things that. So like one of the sort of initial complaints you may have about functional is like you go, yeah, for sure, I have to now describe everything recursively because I can't modify a data structure. So I can't be adding things to an array. I can't update that same array, right? I can't add new elements to an existing array. Of course, I can describe a new array based on an old array with an added element, for sure. So I could create a second array which has got an element in addition to all the other elements in the first array, right? So I can add elements to an array, sure. The results are different. They're different arrays, right? And so your first complaint might be, well, that seems very wasteful and very inefficient because now I'm copying data structures all over the place. And actually the answer is, no, you're wrong, that you don't need to copy them all over the place. So if you know that your language is pure and that nothing can change within the first array, so when I create the second array, I can just add the new element and point it to the first array. Because I know that the first array will never change, cannot be changed, I can actually be very efficient. All I need to do is just store the new element and a pointer to the old array. And that way I have a new array, which actually happens to incorporate the second array as part of it. And because I know it can't ever change, I can never destroy the first array. Does that kind of make sense? So in fact, from an efficiency perspective, data structures can be very efficient if they are immutable, because you can make assumptions about them, like this will never change. So in fact, I don't need to make a copy of it. I can just have whatever wants to use it or modify it, just point to the original one. Do you know what I mean? So that's often like a a sort of like naive misunderstanding of immutable data structures, that it creates a lot of copies. In fact, the answer is it doesn't create a lot of copies because it never needs to, because it can assume that they never change. So in fact, you can just reuse stuff, which is not necessarily true of of a language which has mutable data structure. So if I had an array and I created a new array with some new elements in it, and it just pointed to the original one, if I changed the original one, I would end up changing the subsequent one as well, right? I would create this dangerous situation of like, I'm assuming this is a new array, but it isn't, because when I change the original one, it ends up changing the second one as well. So in fact, in that situation, I should copy, right? I should make a separate copy if I want to defend myself from like weird and wonderful bugs, right? Your point is around recursion, though. And so recursion, you may also think, yes, okay, so recursion is bad because a function calls itself and therefore puts itself on the stack, of course, right? Of course, that's just an implementation detail. So in most compilers do that, yes. So a function calling itself would create a new stack frame, copy up its variables, create a new stack frame, copy up its variables, etc., 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 and create a very deep stack. And of course, we know that a stack has a limited size. So what generally most functional languages that out there, other than completely useless ones, what they'll do is they implement something called tail recursion. And what tail recursion means is it can unwind the loop. So where the compiler detects, hey, this function calls itself, here's a recursive function call, it'll just unwind it into a regular ass loop. So it won't make use of the stack in order to run it. But there are some constraints as to how you write that function so that it doesn't make use of the stack. But you can Google something called tail recursion that most compilers will use, and they'll just unwind it so that you can recursively call it until infinity, the same way that a while loop can run until infinity. But it can feel weird and uncomfortable when you sit down and you say, okay, I need to do like a for loopy type thing, and I don't have a for loop. So well, I do, but I can't like add results to a thing. So it's like, oh shit. Now I need to think recursively. Yeah, absolutely. You do have to think recursively. So when you think about looping through stuff, recursion is the way you do it. Yeah. Yeah. And it is probably more tricky than regular kind of for loop modify stuff for sure. But I would say that it's one of those comfort things, right? It's like you're comfortable in the for loop world because you've written like hundreds of for loops and maybe thousands and years you've been using for loops. So then when you look at recursion, you go, oh, that's weird and it's different and my brain doesn't really understand this. But I would say it's like a practice thing. The more you practice it, the easier it becomes. And in fact, I think like most of for me, certainly I default to recursion rather than for loops. I think I've actually got a cool example of that. So let's just jump to that actually. So this was just a summary of like my boxing idea, is if you can kind of see this combination of boxing different effects. So in our example where we had the kind of like we did that read file thing, then we parsed JSON, then in this example it like counts them or whatever. Those things you can see are just like sort of putting themselves up into the box. And so and then I pass this box back to the runtime and I say, hey, my program's done. It opens the box, and then what happens is it will execute that. And if there are failure states, like I can also describe how those failure states work. You know what I mean? And so I'm not going to get too hung up on that. It's a bit of a weird and wonderful place. So I'll skip that. Okay, we talked about products and versus sum types, and one of the cool ways of thinking about it is just this, like these 4 words here, making impossible states impossible. So I would say to you, when you're looking at your programs and your functions, and you're trying to describe them through like their type signatures or whatever it is, where there are impossible states, try to make them impossible. So in your code, try and make sure that those impossible states are explicitly impossible. Do you know what I mean? So that idea of having an error or a list of records, try and make that an impossible state, right? So because it is in your mind, in your perfect world, it is a scenario that you do not want to support, right? So it's an impossible state. Make sure that your code also makes that explicit. Unfortunately, in a lot of languages, you don't have this concept of the sum type. Maybe you do, like with an enumeration or a union in C, and hopefully you'll never have to deal with one of those. But often there's so maybe in in other languages you might look for something called a discriminated union, or an algebraic data type, an ADT, or a sum type. Or an enumeration kind of makes are similar kinds of things. Unfortunately, enumerations don't often carry that extra piece of information that we were looking for. So remember when the enumeration, so for example, our thing could return an unknown error with an error attached to it, or a result with an array of strings attached to it. Enumerations don't often support the carrying of that extra little piece of information along with them. I think in some languages enumerations do that though, and so that's a good use of enumerations, of carrying that extra piece of information, which is pretty cool. So this is just some like blurb about like what is functional. So functional programming, and this is a guy called Michael Snoyman. He's a Haskellr, but he's very outspoken in the FP community. But it's so think of it, functional programming, as a style more than like a technical thing. Functional programming is not a language-bound thing. It can be accentuated by particular languages. So certain languages make that style easier to adhere to, and others make it a little bit more hard to adhere to. But the style is still a good one because it's about making your code more explicit, right? Yeah, and so like a lot of languages can be considered functional. It's like a spectrum. You have this idea of like pure functional languages all the way back to imperative languages that have a lot of functional features in them. And so I think, yeah. So one way I like to think about this, and this is just like maybe my own internal model. And like I'm not saying guys like write only functional. I'm not. Like that's completely a personal choice that you have to take on board, and it like has big like outcomes attached to them, right? But when I think about these two styles, I see them as being trade-offs, right? So imperative style, it's very easy to get working. Like we saw this, right? We had our 5-line program earlier. It just worked, and it worked in 99% of the cases, but it's very hard to make it correct. So when I talk about correct, it's like this thing is explicit about what it does, and it handles every error scenario, and it makes it explicit to the caller of it, right? It doesn't hide, doesn't throw away information. So where we caught an exception and then we just returned empty records is like it's not really correct. Like it wasn't, the file didn't have empty records in it, right? It was incorrect. We hid that. We just like threw it away because we didn't know how to deal with it, right? So I would say that it's hard to make, using an imperative style, it's hard to make your functions and programs correct. And I'm using like not correct not as in working, correct as in correct. With a more functional style, for sure, it's harder to get working, absolutely. And it's because you have to handle and be explicit about what is correct as you do that. But once you've got it working, often it is just correct. So it's like almost plus naught to go from working to correct very often, if that makes sense. So it's kind of like if you're trying to get to correct, going through imperative is going to maybe hurt as much as functional, but you'll be at correct by the time you're at working, if that makes sense. Okay, so like I've just quickly put up a bunch of languages. I don't know all of these languages. I know a lot of them. And look, schema's on there. But like I would say almost all of these languages to some degree have got the ability to write pretty good functional style code in them. So C# for sure is getting more and more functional over time. In fact, there's a language called Fsharp, which is not pure functional, but has got a whole lot of very interesting things like discriminated unions, ADT, sum types, stuff like that, even into some simpler ideas around side effects and monads and boxing and unboxing and stuff like that, which I think is very cool. And if you followed C#, so I follow C#. I don't write a lot of C#, but I definitely follow their release notes whenever there's a new version. Like you're seeing a lot of the new language features coming in there are like functional language or functional features actually. Java for sure is I would say in kind of the same boat. It's also it's catching up, but there are some really good more explicitly functional dialects within the Java ecosystem. Scala for sure, Clojure, Kotlin, these things have got very much what I would call like at least like they're functional orative languages. You could choose to go both ways, which is actually really cool. So C# and F#, 100%. You can say like, I feel like writing this little function in an imperative way because I'm comfortable with for loops and stuff. But this other little function here, like, oh, I want to be very explicit and I'm going to return some types out of my function. So you can mix and match functional and imperative style very easily in C#, Java, and their ecosystem. So Scala, Kotlin, Clojure for sure. JavaScript is like 100% in the same situation. In fact, I would say JavaScript is probably a lot more tending towards the functional side. And if we specifically look at it like dialects, so the other languages that compile to JavaScript or that are in the same ecosystem, right? So ES6 is JavaScript, right? TypeScript for sure is probably accentuates more like the type system, maybe less accentuation of functional, although I'd say I'd prefer to use TypeScript over ES6 because it does do some cool stuff around being more explicit around types, which I really like. I think type systems are good. Functional style is good. PureScript, we saw earlier, it's a pure functional language. In fact, it even takes you to that pure side, which is like, hey, even effects and side effects have got to be put in these boxes, and the compiler will enforce that stuff. So you can't just have like a console.log somewhere randomly in your code. You have to put that in the box, right? Elm is a very interesting one. I don't know if anyone's ever looked at Elm, but it's a web programming language. And I actually have a cool example. I don't think we're going to have time to like go through it, but Elm is super cool as like a toy language to really like build something in a pure functional way and go through the pain and hardship that is associated with it, but in a way that's pretty fun and interesting, and it's a very limited language. So like it really takes away like this burden of knowing like what is a monad and a semi-group and a functor and all this stuff. It literally says, hey, this is all you got. You got these like 3 tools, and this is how you're going to build web stuff. And try and build web stuff with Elm. I wouldn't like recommend it for like big production stuff, but for toy and learning projects, I think Elm is great. It's really, really cool to get into what are ADTs and all that stuff. ReasonML is another very cool one in the JavaScript space, and this is by the author of React. So if you guys have used React and React Native, I don't remember the guy's name, but he got very excited about functional in actually about 2016. So he built React. He was very inspired by a bunch of things going on, but he wasn't a functional programmer. Not really. While through the journey of building React has realized that actually functional programming is the answer for React, and in fact has created his own dialect on top of a language family called ML, called Reason. And so ML is today, if you want to write ML, you'd probably use OCaml. Yeah, so OCaml is like a dialect of ML. ML is a family of languages, and ReasonML is I suppose like a stepson of OCaml, but compiles to JavaScript using something called BuckleScript, and it very much accentuates the React. So if you like React and you've been writing React in TypeScript or ECMAScript, you may feel the pull to be pulled into ReasonML, and I would say go for it. Go and try it out. ReasonML. It's a functional / imperative. It's not pure, which is really cool. So it's like easy to pick up, easy to go, easy to be productive. You can write for loops if you want, but you can also be like have the power of ML underneath you. CoffeeScript, LiveScript, those are also LiveScript being more probably functional. CoffeeScript maybe more object oriented. But like Python, unfortunately, doesn't have great pure functional or any functional stuff. It has this concept of a lambda. Doesn't really have higher order functions. Unfortunately, like Python is really sucks from a functional perspective. I think it's just painful to write functional style programs in painful. It can be. And so you quite often just default back to like imperative style. Go, I would say, is almost in the same category as Python. It's very anyway, it loves mutation, it loves null, it loves returning nulls from functions, that kind of stuff. Rust is, I would say, quite close to being a almost pure functional language, very functional. C and C++, actually it's pretty easy to flip over to a more functional style. Haskell's pure functional. OCaml is functional, very much on that spectrum. It's not pure. ML is the same. Scheme, I don't actually know that well. Prolog, I think, actually don't know too well either. Other than it's got some other interesting language stuff. So anyway, it's like it's available. You can do functional style in almost everything, even Python. Yeah, I found a cool picture here of actually it's like the satisfaction index of people using JavaScript and its various like dialects. It doesn't have all of them, but it's got like I suppose the most popular 5 dialects of JavaScript. TypeScript 100% at the top. 93% of people are satisfied using it. And TypeScript is a mix of, you can go imperative, you can go functional, you can do both. You can mix them together. Interestingly, PureScript is at number 2 on that list from a satisfaction perspective, and it is pure functional. So it's not even on that like spectrum. It's like hardcore pure. You can't console.log.print. You have to use those boxes and all that stuff. Reason is on there as well. Elm is pure as well. It's also far on the other side of the spectrum. And ClojureScript. So it's interesting that of the like 5 there, I would say 4 of them are functional languages, and 2 of them are at least pure functional languages. And you can see there like increases in satisfaction over time. So like be aware of this stuff, man. Functional, don't run away from it. Ask the hard questions and answer them and experience these languages and see what they do for you. So when I think about functional programming style, and it's like my model for it is like a value model, and it's the value to you as an individual, right? It's a very big world, right? So you've probably, in your past, if you've written a lot of code, it's probably been primarily procedural or imperative, and that's okay, and you got a lot of value out of it, and that's great. With functional, you might be at the start of your journey, or you might be in the middle, or whatever it is, or maybe you haven't even begun, or whatever. This is how I certainly feel, and certainly for me, functional programming style unlocked value. And so I just put it in these like 3 sort of like onion rings. The green one, like I call this minimum viable FP. So taking on a style which is like minimum viable, which is to say, hey, like where I get the opportunity to write this more functional and make this code better, like I get tons of value actually from doing that. And it doesn't have to be complicated and like hardcore functional type of code. It can just be these simple tricks here, which is like immutable data structures. I really believe this is a strong one. So when you return data to someone, or someone passes data to you, it would be nice to have the guarantee that it won't be changed, you know what I mean, in the future or whatever, right? So like that's a very nice guarantee. And I think there's a little example maybe later where we talk about it. Eradicating null. This is like null is such a bad idea everywhere. Like there's no good reason to use null ever. Don't use null ever. Don't return null. Don't accept being returned null. Don't pass null to stuff. Like it's a bad idea. Don't do it. Rather be explicit about what your stuff does. You know what I mean? Either it's a string array or it's an error. What is null? What does that mean? So if I return null as in the place of the string array, what about the poor guy who goes for each on that thing? He just blows up, boom. Do you know what I mean? So use null. Like null is the absence of. It's a weird one because it's not binary, right? So if you think about like what is null, it adds one more state to everything. So it's like, hey, I've got an object, or I don't have an object. Then I have this like pointer to an object, which could be null. So it's like, oh, there's actually a third state, that the object exists, the object doesn't exist, and then my reference to it doesn't point to anything. It's like, oh, that's a third state. It's like, it's terrible. Try and reduce it everywhere. It's almost always a problem to have null. First class functions are also really cool. And our example earlier of JavaScript, where you passed functions into a function and that function executes those functions, those are called first class functions. And they first class because they're passed around just like any other variable would be passed around, or any other value, right? So they're kind of first class. That's the way to think of them. So often a function like map or filter or whatever, those things are quite often first class functions. Yeah. Actually they're higher order functions, which take first class functions as arguments. Anyway, first class functions are cool. I think that they're very useful. And I don't think that they're difficult, and I think they're easy to pick up. So like in wave 1, minimum viable product, minimum viable FP, like those 3 things, like just do that, right? And be aware of them, right? As you move through the onion layers, though, it's like actually there's some cool quality of life stuff that can appear. So the more you delve into some of these things, like the concept of everything is an expression is actually really interesting as well. I don't have a good example here, but like For example, the if statement in JavaScript, unfortunately, is not an expression. And it's quite sad that it isn't, but it should be, if you think about it. Like a switch statement should be an expression. Like everything should have a return value, if that makes sense. And the cool thing about that is like things start to compose together, if that makes sense. Whereas when things are statements and what they're doing is they're intrinsically modifying state of stuff outside of them, if that makes sense. Does that kind of make any sense? No. I could, if we had time, I could give you an example. But anything, everything is expression is cool. Pattern matching is really cool in a bunch of languages. You should totally look at this stuff. And that's, I showed an example when we were handling that ADT and that pure script that we had to do a case match on it. And that's called a pattern match, which then destructures the thing that that particular state is carrying around with it. Hey, it was successful, and here's your list of records. That's a pattern match. That's unpacking that for me. Some types of blah blah blah. There's many other things you could get, and advanced is like it's almost endless. There's probably like more and more layers as you go through this thing. And I would say I'm like getting into this like third level of stuff. Yeah, null, kill it. This one. I don't want to hear any arguments. Why is that not changing? There we go. So there are like other ways to deal with null, like the idea of the nullable type in, I think it's in C# maybe, or Java. In Scala, you would call it like the maybe type, etc. And like that's explicit, because if I call a function and it returns a nullable string, it's like, oh, cool. It could be null or it could be a string. It makes sense to me, right? Whereas if it says, hey, I return a string, and it like turns out that string's null, then screw you, man. Like you hit me with a null when I wasn't expecting it. Rather wrap it up in this thing called nullable, right? Makes sense, right? A lot of languages are going this way. They're getting rid of null by introducing a generic type called nullable or maybe or whatever. To wrap it up to make that code more explicit. Immutable data structures, we talked about it. Here's maybe the last example of code around, and this is maybe just something to stick in your mind, but when I look at this code, right, and I'll read it with you, it's very easy. So it's in whatever language you choose. So x equals empty array, right? So x is an empty array. We're happy with that, yes? Then we go through a for loop. And this looks Python-y, I suppose, because it's got brackets and stuff. So maybe it isn't. And maybe it's neither. So for I in range 0 to 10, so whether it starts at 0 and ends at 10, who cares? But it goes through a loop of 10 or 11 things, right? If I mod 2 equals 0, so that's kind of looking like, is it divisible by 2? If it is divisible by 2, then add I to the array, right? We're comfortable with this, right? And then at the end of that, we're going to go print whatever is now in X. You happy? So it's kind of like it's the even function. It's like figuring out what are the even numbers in the range 0 to 10. You happy with that? So my problem with this, and I don't know if, yeah, is like this code sucks, man. And do you know why it sucks? Because what you said to me here is like X is an empty array, right? So when I ask you, like, so what is X here? I would say, well, it looks like it's an empty array. That's what I would say, right? However, when I print down here, it's like, oh shit, it's not an empty array. It's like got stuff in it. So it's like, well, okay. So what actually is X? Is X an empty array, or is it an array with the even numbers between 0 and 10? And it's like, well, it depends on the like where you are, right? So if you ask that question and you're something here, it's like, who the hell knows? If you ask the question if you were there, it's like, well, I don't know. It depends on how far, whether you've appended an I to it or not, or where you are in the for loop or whatever. So it's like actually, like this is a big freaking like lies everywhere here. Like this is very, very weird. So when I see X as an empty array and later on I print X, and it's like it turns out it's not an empty array. It's like, shit, what's going on here? And it's like, I mean, I'm saying you should ask this. It's like, yeah, it's like, why do I? So it's like, no. So it isn't. Sometimes it can be this full array, but it's like you have to have understood and followed its path through this program in order to know what X is. Do you know what I mean? Does that kind of make sense? So it's like, oh, it's pretty shitty actually, because it's like, oof, in here lies a whole bunch of murky knowledge. So to know anything about X, I must know about the context of where X has ever been or ever been manipulated or whatever. And of course, this is like a very stupid example, but take this to like a big, take it to the extremes where it's like you can know nothing about anything if you can't rely on this statement up here that X is an empty array, right? Do you know what I mean? If it can be modified, then it's like, okay, well, all bets are off always, right? So what's a better way of doing this? So a better way of doing it is to actually make X what he is, right? Which is like X is for in that range of 0 to 10, the list of elements that are filtered for only the ones that are even. Does that make sense? So look, there's no more lies here. X is this thing. And I can put the word const here, right? I can say const X if my language, hopefully my compiler or language supports this thing. So X is always this thing. It's never anything else. So if X is in scope and you are able to print it or do whatever you want with it or calculate with it or iterate through it, it is this. There's no other state it could possibly be. Does that kind of make sense? So like this is a better way of describing X, right? Rather than this. Do you guys agree? So you may be comfortable with this kind of style where it's like, oh, I build up something. I would say to you, wherever you see this, try to replace it with this, because this is much better. Because I can also take X, I could lift this whole piece of code here, I can cut and paste this into anywhere else, and it's like, yeah, it's good. Like X will be this thing, you know what I mean? Whereas I can't cut and paste that there, and like this piece of code, if I want to cut and paste that, I also have to know, but I have to cut and paste that piece of code. It's all like connected. It's all like glued together. And it's like, actually the glue's not that explicit, because it's like, well, where does the glue start and end? It's like, well, it could be anywhere, right? Who knows? It could be anywhere. You've got to like file, search, find X, where it gets used, who knows? And then you're like try and cut and paste all that together and drop that in. Whereas here, this is like totally atomic and beautiful. Like one line, of course, it could be hundreds of lines of filters and maps and reducers and the whole story. But when I lift it out, it's like, yeah, it's complete. Boom, I can drop it in. And so to be clear, this thing filter is a higher order function. So it takes a first class function. I suppose in the scenario of filter, that's called a predicate. So it's a function which returns a Boolean. Anyway, this is just good words to throw around and sound clever. And there's lots of these things. So you can build up these data structures. In most languages, I would pick almost any language and say you can do this in any language. Like there is support for this. So you figure out what does map do, what does filter do, what does fold do, and then I've listed a bunch here: group by, flat map, zip, window, partition, join, all these things. These are these things to build data structures in an expression-y type of way in order for you to like set them to a constant, without you having to iteratively build up data structures. That makes sense? First class functions, yes. Elm, we don't have time. Sorry. Elm looks like this. Maybe we could do something on Elm in the future. It's very cool. You should play with Elm. Try it. Okay, so here's my summary. To be a better programmer, one of the ways to be a better programmer, I think there's many ways, right? Try to make impossible states impossible. Like this is cool, actually. You should look at this. Whenever you write a function, be explicit about like what are the states that can be, so that the poor guy who's calling your function, even if it's you, the poor guy tomorrow who's just woken up and going, oh, I don't know what this function does, it like make his life easier, make the future you, make his life easier, right? Future you. Idea of sum types is very beneficial there. Null is a bug, I would say, in almost all cases. Like don't use it. Don't use it. Immutable data structure is definitely worth thinking about. Try not to put too many lies in your code. So we go X equals empty array, and later on it turns out it isn't. Like that's a lie. And so ideas like const and things like that, sometimes the compiler can help you say, hey, look, you're lying, you're making X something else. Those are good. Like it used to at least default to those things, right? And then make your lies more explicit. So where you do end up having to lie, it's like, oh, I'm lying here because there was a scenario. Don't make all your code lies. And then the last one is like be open-minded to these things, like, and freaking go and check these things, right? So when because you can have this like initial you know, you can choose to respond to new stuff in two different ways. The first one is go, oh, it's horrible, and I'm gonna, like, it's evil for some reason, and I'm not gonna look at it. Or it's like, oh, it's new and uncomfortable. There must be something interesting. Let me go and like look at it, right? So like, try to be more of the latter. So when you see something new and uncomfortable, go, oh, there's something interesting I can learn from this, rather than go, oh, no, this like hurts my worldview somehow, and like, oh, it's going to make me feel stupid or whatever. Like, no, things that make you feel stupid are good, because it gives you good opportunities to go and learn about them, right? And make you smarter, right? You must run at the opportunities to make you smarter, rather than go, no, I'm already smart. And like, no, I don't want to look at this like strange and uncomfortable stuff that people are talking about, because then you will become like, I think that first response is like, you will become a COBOL programmer. That's what COBOL programmers did. They said, oh, COBOL's the best. Like, oh, this new stuff. No, I'm not looking at it. Oh, this new AWS cloud stuff. Oh, what's this quantum computing? What's this like? Oh, I'm not doing it. I'm good at this one thing. Like, no, that's actually not the career that you picked. You didn't pick a career in programming in a language. You picked a career in continuous learning, if that makes sense. And so, what must you do as a continuous learner? Go and find the things you don't know about and go and learn those things. Do you know what I mean? Like, that's the whole, and and apply those things all the time. And then you will be a happy person. If you choose option one, like, I think you will be deeply unhappy, actually. And like, maybe it's the wrong career. I don't know. But I know it isn't, because we've we've spoken to all of you guys. You're all smart, continuous learners. You know, those are the kinds of people we kind of hire and attract, right? And so make up your own mind about stuff. Yeah, that's important. And that's me, guys. Sorry, I've run over time. But does anyone have any questions about anything?
How's it, Tom? I have a
How's
question.
Yeah.
Are there restrictions on what you can do with functional programming? Is like any program can be turned into a functional program, or are there some things you actually can't do in functional programming with functional programming?
No. Yeah, I would say anything that can be done in a program can be done in a functional way. Whether how much like pain you have to go through in order to achieve it is like up to you to make, that assessment. But there's no limitations. So they're it's Turing complete, right? And we know what Turing complete means, hopefully, if you study computer science, is like, they can be done. I would say like there's a whole domain of problems which are probably more suited to a functional style versus a imperative style. But I would say no, there's no limitations, no. No
Okay,
technical ones, no.
And what would be the best way to start just getting your hands dirty, go in and try and write code?
I would say, I mean, if you're keen to dive into that world of pure and what is pure, and then so it comes down to like your personal preference. If you want to dive into pure and then figure out how you make your way back to productivity, then I would jump into Elm. Honestly, go and have a look at Elm or Pure Script. I'd say Pure Script is like, there's some scary shit in there, but I think you can be Elm. Elm is like constrained enough. But it's not a general purpose language either. It's only for web programming. So you can only build web apps using Elm. You can't run like a command line script and like read records out of a JSON. It doesn't have any of that stuff. So it's only for building web applications, which is really cool. So it's like in that limited sphere, Elm is beautiful because it's really stripped itself down to what is useful in that domain. And I think it's very easy to reason about. The other option is like, if you prefer to be less uncomfortable, then it's like, well, take the language that you like, C#, Java, whatever, JavaScript, and then move your way into like using more higher order functions, using more immutable data structures, that kind of stuff. And maybe you're like, so it's like, which way do you come across the bridge? Because at the end of the day, you probably want to be stronger across both of those things. Do you know what I mean? So it's like, if you want to dive head first, go for Elm, man. Go check out Elm. You could check out Pure Script. Haskell, those things will teach you a ton, but you may go down like a rabbit hole of years. So when I started with Haskell, it was probably 2015. So I knew Fsharp pretty well, and I wrote a bunch of Scala in like the early 2010s. That was really my first introduction to like what is really like functional, like what are the functional ideas. Fsharp was really cool, which I think is an ML or is it? I think it's an ML derivative. So I really enjoy that ML idea. So maybe Reason is also Reason ML is a good language to pick up. But then I just like got into Haskell in 2015, and I just found it like it was far too much. It was like, oh shit, okay. I gave myself a few weeks to learn this language, in evenings, and it turns out I need actually like months. And slowly from 2015, I put it away for like a long time, picked it up again, put it away, picked it up, put it away. And I'd say today, like I still would not comfortably write Haskell, but I'm finding PureScript to be potentially like a more productive version of Haskell. But it's like, it's taken years to become comfortable. I'd say go look at Elm would be my answer. Yeah.
Okay, cool. Thanks, Tom.
Anything else, guys? Any comments? No? Okay. Then I think we are done. Thanks everyone for joining today. And I'm really sorry about the load shedding crap that happened on Wednesday, but I'm glad we managed to get it back together so quickly. And actually we spent a bit more time, so maybe that's a good thing. And you guys are welcome to reach out. All my contact stuff was at the beginning, right? So you know how to reach, like on your teams, man. You guys can speak to me. I like this kind of stuff. I really like dumb questions as well. So if you can fire dumb questions at me, I'm very happy with those things. That is for sure. I'm trying to get to the beginning, but it's going to take too long. Okay, so I'm going to click hang up. Thanks, everyone. Hope you guys have a good Friday and a great weekend.
Thank you. You too.
You too.
Thank you.
Thank you.
Cheers,
Thanks so
guys.
much.
Ciao.
Cheers.